Hello, everyone, and welcome to another episode of our Hopsworks 5-minute interview. And this is a special one for me. I'm actually doing a New Year's special, let's call it like that, right? And I have my friend, colleague, and boss on the other side of this Google Meet, and that's Jim Dowling. Hi, Jim. How are you?
Hey, I'm great. I'm great. Thanks, Rick.
Welcome on this interview. I've spoken to you about the format, so let's dig right in. Could you just introduce yourself and tell us who you are and what do you do at Hopsworks, and give us a little bit of a feel for that?
Yeah, my name is Jim Dowling, and I'm CEO, co-founder of Hopsworks. I have a background primarily in research. Apart from a stint at MySQL, I did a little bit at Intel as well at some point, but I've worked a lot in research. So, I did a PhD in distributed systems and AI, reinforcement learning back in 2004, I think I finished. And then I got into systems research back when I moved to Sweden. I live in Stockholm. I'm originally from Ireland. And the company kind of came out of ideas from both MySQL and then work we were doing on scalable distributed deep learning and machine learning. And that's kind of how the company came about. So, I've been working in AI since, I think in the 90s, I did my bachelor's on hidden Markov models, and I've been working in distributed reinforcement learning in the 2000s. I couldn't get research money for that to continue. I moved into big data. It wasn't cool. Reinforcement learning was not cool in the late 2000s. Yeah. And, and then now obviously I taught the first course in deep learning in Sweden, as well at KTH, which is kind of surprising considering I'm a systems guy. Yeah. But yeah, so I have a pretty, long background in terms of not just AI, but also systems research.
I mean, people don't realize this, and I certainly didn't realize this until some time ago, that, this is actually quite an old academic field, right? It's been around for quite some time. It's not something that came out of the blue in the past, ChatGPT era.
Yeah.
It's been around.
It's funny enough, like in terms of research, we had a good research group at my old university at Trinity College Dublin, and in the UK and Ireland have always been strong in AI. And other countries like France, Sweden, where we live now, less strong in AI, but huge investment recently by the richest family in Sweden, the Wallenbergs. And you can see the States has always had some, relatively good low-key, in Canada, good research in AI. But those early investments we've seen kind of pay off a lot. So we can see a lot of the really good stuff coming out of the UK, France, Canada. We wouldn't be normally big players in the computing scene, but because they had that leadership in the early days, it's followed through to having a lot of the big breakthroughs, I guess, in the last 10 odd years.
And is that also how, like the work on feature stores and, work at Hopsworks has emerged? Is that a direct consequence of the work on the ML and distributed systems, or?
I mean, that's kind of, from our perspective, what happened was we built this scalable data science platform that we call Hopsworks, and we got venture capital to build it as kind of a next generation data science platform. So you had these data science platforms that ran on one server. I won't name names, but there are a bunch of them out there. And we said, well, data science should be, using lots of servers, using GPUs, because we have deep learning. And we had built a kind of a two-layer architecture. We stored large volumes of data on this file system called HopsFS that we won IEEE Scale Prize for. And then we had this metadata layer, which is a scale-out layer called RonDB now, which was MySQL cluster at the time. And we built this as the architecture. And then when I saw the feature store article by Uber wrote a blog post basically on it, I said, hang on, we have that two-layer architecture. And if Uber have this problem of managing data for machine learning, everybody else who's going to be doing machine learning at scale is going to have the same problems.
Yep.
And we have an architecture already in place that fits this. We have the historical feature data can be stored in the scale-out file system. And then the most recent feature data that we need for online machine learning, we need low latency access to it. We can store that in our online store. We call it the low latency row-oriented database, RonDB.
Yep.
So it was just basically a question of finding someone who could work on it, somebody who's really motivated within the team, because we were building this thing. We already had we had a customer and we had like a pipeline of things to do. And eventually we found someone, and then we did a first version. And it was crickets, like silence. I think Feast came out a few weeks after us, which there wasn't that much of a time gap between it. I think we were the very end of December 2018. Feast came out, released a blog post end of January 2019. And then I think the first event was like a workshop in the States in the Valley in March, where we had a couple of other companies attended, and not much happened. I started giving some talks, But we then got a customer, Paddy Power, the largest betting company, around later in the year, and then we realized this is actually something we should focus on. So there is a market for this. We can sell this.
So can you tell us a little bit about why you think this is such an important topic in general, not just the product and the company and everything, but why do you do this? Why do you think this is important?
Actually, one thing that had a big influence on me when I was early in my career was there's a researcher called Richard Hammond. He's quite famous in that he did the Hammond series and things like that. But he basically he always asks the same question to every researcher: what's the most important topic in your field? Yeah. And then why are you not working on it? Right? Yes. And if you're in computer science right now, I can't think of a more important topic than AI. I mean, it's redefining how we are as a species. If we're not the most intelligent sentient being on the planet, that's pretty revolutionary. Now, we're not there yet, but we're in absolutely exciting times, and the pace of innovation is massive. Now, although I have a background in kind of computer science, systems research, and AI, I'm not a theoretical AI researcher. I'm a systems person, so I got drawn into where my skill set really kind of comes to the fore, which is how do we provide system support for these AI applications, and that ended up being primarily at the data layer. So how do we manage the data for AI? So to be able to make that data available for training models, but also for building machine learning systems as well. So whether online or batch applications.
Really interesting. So where do you think this is going in the next couple of months and years? What are some of the big trends that you're seeing on the horizon? And I know that we could easily spend a night at the bar on this topic. But,
yeah, I mean, look, back in the 90s when I did my undergrad, we always heard about Moore's law, and Moore's law said the number of transistors on a chip doubles every 18 months, and we kind of knew that the physics of Moore's law would eventually kind of wear out, which it did in the early 2000s, like around 2004 or 5. We had to go multi-core. We've seen the same happen for deep learning. So there was a pretty interesting kind of heuristic that came out a few years ago, which said that for many different classes of deep learning systems, from anything from image classification to natural language processing that we're seeing, so translation in Google Translate, or large language models, we can see roughly with an order of magnitude increase in the amount of data and the model size, we can see a logarithmic improvement in model performance. Yes. That's been a kind of a rule of thumb. So, when Sam Altman goes out and says, well, I know that if I invest another $1 billion in GPT-5 or 6, I know I will see this much improvement. And therefore, if I have that much improvement, I can quantify how much value it will create. Yes. So they're able to actually predict it based on this scaling law that we've seen for the last 5 years, really. Yeah. So the question everybody has is, like Moore's law, we knew physics, like we knew in physics. Now, the equivalent to the speed of light for us is the amount of data available to train these models on. So we're going to, we're running out of let's say human-generated text to train large language models on. Where will the new data come from? Will it be generated by LLMs, or will we hit those scaling limits soon? I think that's the fundamental question. And when we hit it, what does that mean? So I think the really interesting thing that will probably happen is that we'll invent new techniques. In particular, Jan LeCun talks about this quite a lot, that it takes a huge number of training examples to get a large language model to learn something new, like arithmetic. You need 100 billion parameters in your model to be able to do simple addition, and then multiplication is still problematic. But when we learn new abstractions or concepts and we're able to add some linearity on top of these models, it's getting a little bit technical there, but I think being able to learn new behaviors with a smaller number of samples, then we'll make another wave of progress will jump. But it's very hard to say when that will happen. But I think it will happen.
Very interesting.
We're in some really wild ride. Really.
So one more question, and then we'll wrap up. But what should people absolutely read or watch, or the one thing that you're like, this is a game changer for anyone who wants to get into this field? Is there anything that you could recommend? I mean, I know you're a academic and a teacher, so you probably have a ton of things that you could recommend.
Yeah, I mean, look, what I would recommend not to do is get interested in the politics of this. There's been a lot of politics recently. Just ignore all that. That's nonsense.
Yeah.
I'm a builder. I think the best thing you can do to get started in this space is just build things.
Yeah.
So build machine learning systems. So I'm biased. I had a course on serverless machine learning, and the first tutorial, you build a machine learning system, a real one with real data coming in, making predictions, and not just one prediction. So I think, this going from static data sets that we've had traditionally in machine learning systems, that you train on a static data set, you evaluate on it, you're done, building a real system that takes real data, makes predictions, and keeps adding value. I think if you work on that and look at that, that's probably where you can make most impact most quickly. I hope you can use a buzzword like MLOps to tell you about it. It's really just, Python programming. You don't need to get into too much system details to actually build real things.
That's very true. I mean, we have a bunch of those tutorials on the Hopsworks GitHub repo. That's how I kind of got started in the recent couple of
years. Yeah, and I think, look, if you can within a couple of hours take your location where you live, find, for example, an air sensor nearby that's making its measurements available on the internet, you can now build a prediction engine to predict air quality where you live.
That's very true.
And it can help people in your community, and you can do it in a few hours. And I can bet you nobody else is putting those predictions out there. So you can have this prediction service air quality. That's where we are right now, that, we have the tech, but just need people to actually do it. And if you're one of the ones doing it, great.
That's a great suggestion. Thank you for that. Well, Jim, we're going to wrap up. Thank you for taking the time to talk to me, and happy Merry Christmas and Happy New Year, right?
Thanks, Ray.
And I'm sure we'll talk soon. Thank you, man.
All the best. Thanks. Bye.